Hey everyone, Teacher Chang here, and today we're going to go ahead and graph some absolute value functions. So let's go ahead and take a look at what we need to know in terms of our absolute value function. Now we're going to be looking at the standard form, but this one is just the very basic. So we're not going to deal with anything that has to do with a horizontal stretch. However, we will deal with a vertical stretch, and that's what our A value is going to represent. So if we take a look at our A value is going to be our vertical stretch. Now our vertical stretch will have some type of dilation by that A value. So if A is equal to 2, well, that means we're going to stretch out our graph to twice its size. If the A value was 3, then it'll be 3 times its size. So basically, this is what it's going to look like if I have a graph, our parent function. Let me go ahead and change this highlighter back to a pen. We have our parent function, which means that our graph looks like this. If we have a vertical stretch of 2, that means it's going to be twice its size. Now we're going to start off by anchoring our graph with that vertex, and we're going to stretch it out twice its size. So if A is equal to 2, that means we're pulling on the graph in an upward direction. Think of it as a rubber band. And if our graph was like a rubber band and we take these ends and we pull it up, well, that means our graph is going to get a little bit skinnier like this over here. So this is what's going to happen if we have a vertical stretch. We're stretching it out. Well, that's only going to happen when the A value, the absolute value of our A, is going to be greater than 1. Now, if the absolute value of our A happens to be between 0 and 1, well, that means our graph is going to be pushed down. And if our graph is being pushed down, that's called a vertical compression. That means the dilation might be a half. So if A is 1/2, that means it's going to be pushed down to half its height or half its size. So that's when our absolute value of A is between 0 and 1. And then we also have another characteristic that this A value shows us, and that's when it is a negative. If A is a negative, well, that's just telling us that our graph is going to be reflected across the x-axis. In other words, our graph will open down. So again, let me fix that really quickly. So it's going to open in a downward direction like this. So it's flipped upside down. And again, if that absolute value of A is greater than 1, it's going to get skinny. If the absolute value of A is going to be between 0 and 1, well, then it's going to get a little bit wider. All right, so that's what the A value tells us. Now the H value is going to go ahead and tell us our horizontal shift. Now notice that there's a minus sign in front of that H. So when we have that minus sign, it's going to feel like the opposite of what we're thinking. So H represents, again, our horizontal shift, which shifts our graph to the right or to the left. And again, it's going to feel like it's moving in the opposite direction. So if it says X minus 2, well, that's really moving to the right 2. I know we want to think that it's moving to the left 2, but even though it says minus 2, it's going to move to the right 2. So it's going to feel like the opposite direction because of that minus sign. Now, the K value is going to be our vertical shift. Now, notice I included that positive sign, and that positive sign means it's just going to feel like what it should. So if it says plus 2, I'm going to go up 2. If it says minus 2, I'm going to go down 2. Now, the H and the K together will give us our vertex. So that's our starting point when it comes to graphing. All right, so we're going to take a look at a few examples here, and each one will be slightly different so that we can see how these characteristics are being played out. So we're going to write out what are these transformations in words, so what's happening to our graph in words, and we're also going to go ahead and show it on the graph. So here we have our A value equal to 2. Well, what does that A value mean? Now remember that A value is going to be a vertical stretch. So we have a vertical stretch, and I'm just going to abbreviate this. So we have a vertical stretch, and it comes with a scale factor, and that scale factor, so with a scale factor of 2. It's whatever that A value means, meaning that it's being stretched out twice its height. Then we have our minus 3. Now remember that minus 3 is going to be the opposite. So H is equal to positive 3. And that means we're moving to the right 3. And then we have our positive 4, and I'll go ahead and change the color for that one. So our positive 4 is our k value, and that 4 means that we're going up 4. So those are the 3 things that we know about this graph. Now what we want to do, and I'm going to go ahead and underline this 2 with a green just to be consistent here. So what we're going to do is we're going to take our h and our k value, and the h and the k value combined will give us our vertex. So our vertex will be an ordered pair, and that's pretty much our starting point. And that's our h value, which is 3, and our k value, which is 4. So I'm going to go ahead and start off with my vertex at 3, 4. So that means I'm going to go right 3 and up 4, and here's my point. So there's my starting point. That's the vertex. Now what we're going to do is we're going to take our a value and we're going to look at it as if it was our slope. So this is our a value of 2. Well, 2 is the same thing as 2 over 1, so that means I'm going to go up 2 and over 1 from our vertex. Now because it's a slope, we could continue to do this over and over again as many times as you want. But really you only have to do it once because it only requires 2 points to draw a straight line. Now, we are going to do it to the opposite direction as well. So I'm going to go up 2 and left 1 as well. Because in the end, we know that our absolute value should be in that V shape. So now that I have this V shape, I can go ahead and pull out my straight edge. And I'm just going to draw our graph here. So I'm going to go ahead and start from my vertex. And I'm going to connect these dots here. And I'm going to do the same thing on the other side. We're just going to connect these points, and this is what our absolute value function looks like. All right, so there's our graph for the first one. All right, so let's go ahead and take a look at our second example. And again, we're going to take a look at several examples, and they are going to be slightly different from each other. So let's take a look at this next one here. So this time, very, very similar to the previous one. So I'm not going to jump to something very different right away. So we're going to gradually make things different. So here we have A is going to be 1/2. So that means we still have a vertical stretch. Some people will call it a vertical compression. A lot of teachers will still call it a vertical stretch. But the scale factor, so with a scale factor of 1/2. So it's going to be half its height. So that's going to be our A value. That's this 1/2. All right, the 3. So that's plus 3 is our H value. And remember, it's the opposite of what it says. So really, we're going to the left 3. And our K value is going to be that -1. And that means we're going to go down 1. So with the H and the K, we can go ahead and write out our vertex. And our vertex is going to be our 3, -3, and our -1. So it's our H and our K. So let's go ahead and graph this. Again, we start off with our vertex. The vertex is at -3, -1, which is located right over here. And then again, we're going to look at our A value, which is kind of like our slope, like I said earlier, which is 1/2. So that means we're going to go up 1 and over 2. And you can do it as many times as you want. You can do it once, you can do it twice, you can do it 3 times. You can do it as many times as you want. Just make sure you go in both directions. So up 1 and over 2 the other direction as well. And that's going to give us our V formation. Once you have enough points that you like, we take out our straight edge. We'll draw our straight lines going in both directions from the vertex. So on the left, it'll look something like this. On the right, it'll look something like this. Okay, so there's our graph for our second one. So your teacher may be expecting you to go ahead and write out your transformations in words. And when they ask you to write out your transformation in words, that's just saying you have a vertical stretch of some scale factor. You have to move to the left a certain amount of times or move to the right a certain amount of times. The same thing with up and down. So that's what they mean by stating the transformation in words. So let's take a look at this next one. Again, slightly different. And we can see that we're missing something here. So let's see what we do have. Well, we do have our A value. Our A value is -3. So this is actually telling us 2 things with our A value. The first thing here is that we do have a vertical stretch. So we have a vertical stretch, and the vertical stretch with a scale factor of 3, not negative 3, but 3, because the negative sign is actually telling us that we have a reflection. So we have a reflection over the x-axis. So now we know that our graph is not opening up anymore, but it's opening in a downward direction. All right, the next piece that we have here is that we're missing our h value. So in this case, we can look at it as x minus 0, which means h is equal to 0. So we're not shifting it left or right. So we don't have to write anything in terms of our transformation in terms of left and right. But we do have a k value. That k value is this negative 2. So k is equal to negative 2, which means we're going to go down 2. So in terms of our transformation in words, we have a vertical stretch with a scale factor of 3. So that's our first piece here. And then we have a reflection over the x-axis, so this piece here, and we have a downward shift of 2. So that's what I would write down if we were to write out the transformation in words. All right, so let's go ahead and graph this. And to graph this, I need my vertex. And remember, the vertex is my h and my k, so that's going to be 0, negative 2. And that's my starting point. So 0, negative 2 is right over here. And again, we're going to take a look at our a value as if it was our slope. Now, negative 3 is the same thing as negative 3 over 1. So that means I'm going to go down 3 and over 1. And you can continue to go down 3 and over 1 as many times as you want. And again, go in both directions. So down 3 over 1, down 3 over 1. And we pull out our straight edge and we'll draw our lines. So I'm going to go ahead and draw this V shape, but the V shape is upside down. And again, the reason why it's upside down is because our a value is a negative value. So we have a negative a value. That's why it's going in a downward direction. Okay. Now notice that the graph is also skinnier because we have our a value being, or the absolute value of our a value being greater than 1. All right, let's take a look at the next one. And this next one, again, slightly different here. So in this particular case, we're missing quite a few things, and I left some space here for a reason. Because when we look at our a value, it looks like the a value, there's no a value here. And a lot of people, common mistake, people think that the a value is 0. It's not. The a value is 1 because we're multiplying here. So multiplying 1 times the absolute value of x minus 1, well, that's the absolute value of x minus 1. But if we put in a 0, 0 times anything is 0. So we can't put a 0 here. So a can never equal to 0. So a will never equal to 0. That's something that we got to remember here. All right, so with this in mind, there's no vertical stretch. There's no vertical reflection. There's no reflection here over the x-axis because even though we're missing that a value, there is a 1 there. So keep that in mind. So a is equal to 1 in this particular case. We do have an h value. The h value, again, it's not negative 1, but positive 1. Very good. And then we also have our k value. We're missing that k value. Well, that k value is 0 in this case because we could add 0 and still looks the same. So k is equal to 0. So what does that mean in terms of transformations? Well, I don't have to do anything for our a value if it's equal to 1. I do have an h value, which is positive 1, and that means we're going to the right 1. And because we don't go up or down any, that means the only transformation that I'm going to write out in words is going to be that the graph is shifted to the right 1. So now I'm going to go ahead and write out our actual vertex here. So the vertex, again, is our h and our k. So our vertex is going to be at 1, 0, which is located right over here. And because the a value is positive 1, that's our slope. So that means I'm going to go up 1 and over 1 and up 1 and over 1 as many times as you want. And again, we're going to go in both directions. So up 1 and over 1. So the more dots you have, the easier it is to draw that straight line, especially if you don't have a straight edge. But again, you really only need to do one set of points here. So I have one going in this direction, and we have another one going in the opposite direction. and this is what our graph looks like. And again, don't forget those arrows at the end. Okay. All right, so that's pretty much how you graph your absolute value functions. Remember, you should be able to state the transformation in words just by looking at the function and then be able to locate that vertex and then use that a value to go ahead and find your other points. And again, look at the a value as a slope. All right, I hope this helped out. If you have any questions, go ahead and leave a comment. And don't forget to like the video and subscribe. All right, good luck, enjoy, and have fun.